So the next thing we did after the activity was to sit down and say, oh, so what exactly happened here? We talked about the fact that this is a pretty typical water cycle diagram, and that the biggest problem is the fact that evaporation they have labeled up here above the clouds, when we know in fact evaporation first really needs to get going by the radiant energy of the sun. So we first need to have a little bit of radiation in there. And the radiant energy from the sun is able to warm up the liquid and change it into a gas. That gas then is drawn up by the warmer, less dense air into the upper atmosphere, and up in the upper atmosphere, as we said, it is cool. Down here it's a bit warmer, because in the entire troposphere it cools as you go up. So the gas molecules rise up with the warmer air, start to condense onto the particles of dust, and then either fall out because they become more dense, depending on the temperature, as either snow or hail or sleet or simply rain. That completes the last of our water cycle. So the water cycle that we're talking about is a little bit more complicated than simply the diagram that we might have looked at in the past. So the big ideas here are radiant energy through waves or rays. Convection is this movement of material based on differences in density or the flow of matter. And then conduction, that is the movement of energy through touch. So 3 movements of heat. The next part would then be the kinetic theory of matter, which we talked about, and which is a complicated name for saying solids are one state of matter, liquids and gases are another, and that as you add energy, you melt, you evaporate, and as you take energy away, you condense, you freeze. So in our case here, we're going to be talking about the radiant energy from the sun causing the gases to rise up and to conduct out their energy. So the last thing was to take all of our materials together and start to put them in the way that we use them. So the first thing we did was to take our top, and we wanted to make sure that it was upside down and inside our bottle. So we took that and we moved it. Well, we might as well put in the water there. Put the cup in. Then drop our top down inside. Get the ice and put it inside. And at that point, now we start the explanation. So I said the best way is to take and talk about the energy of the sun. So the first thing that we have here is the energy of the sun is called radiation. So radiation, laser waves traveling through the atmosphere to our water. That water then gets a bit warmed up right here on the transition between the liquid and the gas, and that's called evaporation. It's going to rise up because it's warmer through convection, and then it's going to eventually get all the way up here and touch this surface. The energy is going to conduct into the ice. So I'll take a little small one there. We'll shrink it down to show how it moves out of the bottle and into the ice. So now our energy's gone, and we can therefore change it back from a gas to a liquid. That is going to allow it to run down the edge and drop into the cup. Turn that around and give it a little shrink down there. So there we have our movement, and that we know is called precipitation. So in the end, we've got the radiant energy of the sun warming up the liquid. The gases change, the liquids change to a gas, rise up because it's warmer, and the cool air is going to drop down through convection. It's going to touch and lose its energy through conduction, and then the gases are going to be changed to a liquid. It'll run down the edge and drop in as rain, called precipitation. Conduction, convection, radiation, and evaporation, condensation, and precipitation. Rain in a bottle.